Have you ever decided to research a really nice galaxy on Wikipedia, only to find that next to its type, there's a bunch of weird capital letters, bracketed lowercase letters, and sometimes even some weird Roman numerals? Today I'm going to briefly be going through what some of those letters and numerals mean, so that hopefully you may be able to decipher some of these when you want to do your own research on galaxies. Galaxy classification is mainly a morphological style of classification, i.e. we're mostly just looking at the looks and appearance of a galaxy. The modern galaxy classification systems are mostly based off of Hubble's tuning fork, which was sort of coming along the right lines but was slightly incorrect. This is where Hubble essentially assigned spirals as late type galaxies and ellipticals as early types, and from what I can gather, essentially this was a classification system which assumed that galaxies were sort of evolving through to spiral types. However, we know now that this isn't really the case. The modern classification system we mostly use today, with a little asterisk there, was invented by Gerard de Vaucouleurs, and this is essentially what we'll be talking about today, plus a couple other extra bits. So before we actually talk about classification, let's talk about the four main types of galaxies that we see in the universe today, starting off with ellipticals. Ellipticals are mostly featureless, hazy blobs of yellow. Ellipticals are, like I just said, very yellow, but can also be quite orangey, sort of red, and that's because they are mostly filled with very old stars. And we expect that many ellipticals are actually the product of merging galaxies, so this might actually be two spiral galaxies that have merged together to form one big elliptical ball, essentially. And so that would also explain why these elliptical galaxies look quite old, of course, with all the very old yellow stars. And that also, I'm guessing, is why Hubble accidentally thought that these were very early typed galaxies. Another reason for this idea is mainly the fact that ellipticals are ridiculously large. When it comes to galaxy clusters, the CD, so central dominant galaxies, tend to be ellipticals, and yeah, they're way larger on average compared to the spiral and lenticular galaxies. Most galaxies are actually spiral galaxies or even irregular galaxies, but these irregulars tend to also have some sort of spiral features which we can sort of discern from the pattern of the stars themselves. Spirals tend to be characterized by a very small bulge in the center where you see the majority of stars, and in the case of the Milky Way and very similar spiral galaxies, this tends to be a little bit more yellow. And then alongside that, you'll have these beautiful spiral arms. You can have different numbers of spiral arms in sort of different shapes and different amounts of winding upness, if that's even a phrase. And yeah, these I feel like are some of the most beautiful galaxies in the universe. The Milky Way is of course a spiral galaxy as well. Now, we've actually covered irregular galaxies on the channel before very briefly with galaxies such as Hoag's object, and also the top 5 peculiar galaxies, which I believe all of them are irregulars or groups of irregulars. These are quite hard to actually talk about morphologically because of course they're irregular. They're just very interesting shapes that are neither spiral nor elliptical nor lenticular, which is what we'll be talking about in the next bit. Of course, next up is our final category, and that is lenticulars. These I find a little bit hard to describe, but if I show you a bunch of pictures as I'm talking, I think you can sort of see that they sort of all look the same in a little way. So lenticulars are actually a mashup of elliptical and spiral galaxies. You can see in a lot of them, they've sort of got what looks like spiral arms, but they've also got this very sort of solid looking core that kind of looks like a star in some pictures. How close a lenticular looks to a spiral or to an elliptical plays a big role in its classification, which we'll now get into. So as we're going through, I'm going to find a way to actually display the classification system somewhere around me. I might have to move out the way, but I think we should start off with ellipticals since they're the easiest to classify. When it comes to classifying ellipticals, it's really very simple. With an elliptical galaxy, its type is usually marked with a capital E, that stands for elliptical, and then it will be followed with a number between 1 to 7. I have seen numbers go from 0 to 7, but that's for different classification systems that all kind of really are based on the same thing. An elliptical in which we're either looking straight down through it, or essentially a bird's eye view, or has a very circular shape, is given the number 1, so we're essentially looking at it face on. And then ellipticals that we're looking at it at a slightly more bigger inclination, we give through 2 to 6, and then those that we see edge on are given a number 7. And that's about it for ellipticals. It really is that easy. I think next up we should tackle spirals, since they're actually one of the harder ones to classify. So for spirals, we start out by determining if there is a prominent bar or not. So if the spiral looks pretty plain, so we've just got a circular bulge, nope, a spherical bulge actually, and then spiral arms, we just give it the letter S, that's capital letter S. If it does have a very prominent bar, we give it capital letters SB, and if we're not too sure, we'll give it SAB. Now we want to go on to classifying and quantifying just how very well defined it is. So this is where you see the lowercase letters that are unbracketed come into play. If we have a very large bulge compared to the entirety of the galaxy itself, and very tightly defined spirals, we give it the classification A, that's the lowercase a. And then on the other end, if it has a very small bulge and very loose spirals, we give it the classification D, so that's the lowercase d. In between, we actually don't go A, B, C, D, we actually go A, B, B, C, C, and C, D, and then of course D at the end, which will sort of discern between varying levels of tightness of the spirals. On top of that, we've also got where the spiral arms actually terminate. And these are defined by the lowercase letters that are in brackets. I usually see them in between the capital SB and then the lowercase like A, B, C, D. But I have actually seen them at the front of the classification as well, so just be warned of that. So if the spiral arms actually terminate at the center of the galaxy, we give it a capital, no, not a capital, a lowercase bracketed S. Of course, S stands for center. If it terminates at the inner ring, which is just slightly further out from the center, we give it a bracketed lowercase r, and if they terminate at the outer ring, we give it a bracketed capital R. If there is some uncertainty between what the inner and outer ring is, or if it's sort of the galaxy seems to exhibit some sort of transitional feature and no clear sort of definition, sometimes in very rare cases you will see lowercase r and uppercase r within brackets instead of just one or the other. So most spiral galaxies will have the capital S, SB, SAB, lowercase A, B, C, D classification, and then also the bracketed letters as well. But sometimes you will also get their luminosity class, which is the Roman numerals. And as you'd expect, luminosity class defines, that's right, it's the spiral definition, not the luminosity, of course. So luminosity class goes from 1 to 5, or V in Roman numerals, with 1 being the most defined spiral arms and 5 being the very least defined, or flocculent as we commonly call them, spiral arms. I think Messier 64 might actually be a flocculent galaxy, I can't remember, but I can actually remember what it looks like, and it looks like a very fluffy black cloud. So I can definitely see it being a flocculent galaxy, and I can definitely see how the luminosity class might come into play or be quite important sometimes when classifying galaxies. So I think we've covered the majority of spiral classification things, components if you will. So I think it's best if we move on to lenticulars now. So I've seen a slight bit of conflict with regards to how we classify lenticulars, or what the classification actually means or signals essentially, but I will just go through both versions just to make sure we've covered all ground. So we first start off by looking at the lenticular in question and seeing if there is a bar or not. If it's a plain galaxy which is unbarred, we just give it the S0 classification, and if it does have a bar, we give it SB0 classification. So in this case, the naught here is a 0 as opposed to an O. Now accompanying the S0 or SB0, we usually have a subscript number. And in the case for plane galaxies, so S0 galaxies, it will go from 1 to 3, so we'll have 1, 2, and 3, and these will essentially tell us the amount of dust absorption we're seeing in the galaxy. 1 corresponds to very little to no dust absorption, with 3 corresponding to a lot of dust absorption. And I thought that this actually was the same for the SB0 case as well. So SB01 was a barred lenticular with very little dust absorption. But sometimes I have seen that the 1 to 3 can also signal how prominent the bar is. So these can be interchangeably used, I've noticed, so you have to be a little bit careful. So in this alternate case, SB01 would be a very prominent bar, and then SB03, I hope I'm saying this all right, is very weak bar, but I think it can also mean whether or not it has a lot of dust absorption. I'd assume both cases reference dust absorption in the absence of any evidence otherwise, so I'd just go with that. Okay, our final class of galaxies are the irregulars, and this is where, I'm not gonna lie, my knowledge is a little bit more weaker and classification can get a little bit more crazy. So with an irregular galaxy, we usually assign it an uppercase I, IAD with D being lowercase, or SD with D also being lowercase. However, if it has a very prominent bar or very strong spiral feature, so it very closely resembles a spiral, we either give it IB, or you also see SBD with, of course, D being lowercase. And if you're unsure, it's IAB or SAB with a lowercase d. I know it's confusing. I'm gonna put a picture here to explain it and try and make it as simple as possible to interpret. Now, if we notice that the galaxy is, I think it might be called Magellanic in type, i.e. it doesn't really have that big of a bulge, if any bulge at all, or it's very dim, we usually change this lowercase d to a lowercase m to signify that. We can also add the bracketed S, R and uppercase R if you're able to define sort of where the spiral features terminate, and of course you can add luminosity class as well if you're able to do so. There's no one stopping you. But if you find that the galaxy is totally irregular, you really just can't really make out anything at all, any big structure, usually these kinds of galaxies are just given a blanket IM, so capital I lowercase m, and that's just it for its classification. Something I've also noticed as well is that with some irregular galaxies, I think a lot of astronomers try to classify it as though it is just a regular spiral or elliptical galaxy, but they'll add on just a PEC, so peculiar, at the end of it as well. And this is what I found really interesting, is that despite us going through all of these little components that make up, a type that we can assign to a galaxy, a lot of it hinges on whether we actually think it should go through the spiral process method of definition, or the elliptical way, or lenticular, or irregular. And so the actual classification system is very highly subject to a lot of opinion as well. And I'm sure this is also the case in some of these small components that we've just talked about as well. So if we look at, for example, the small bulge well-defined tight spiral arms bit, so the A, B, C, D part of the spiral classification, you can definitely see that if you take, a couple images of a galaxy and grab a team together to try and classify this specific galaxy in mind, you might actually get quite a few varying opinions. This was definitely the case in my second year astrophysics exam, in which I think my lecturer had to give some leeway on the classification types, because, not everybody will agree that this specific galaxy is an SAB lowercase b type galaxy. They might actually think it's a BC type as well. So, you do have a lot of leeway with this, but that's why astrophysics is such a collaborative, subject. Well, I hope at least, even if you might not be able to classify galaxies yourself and come up to the same conclusions as maybe the team at ESA or NASA, hopefully if you do see those classifications, you should now understand what they actually mean and what they're actually talking about with regards to the galaxy, whether it be the spiral features or how we're viewing the galaxy in the case of ellipticals. So I hope you learned something new, and I'll see you next time.